The James Webb Telescope has provided the clearest image of Proxima b in history, revealing astonishing insights about this potentially habitable exoplanet. As we embark on a journey through space to uncover the mysteries of Proxima b, we seek to find out whether it could be the next Earth. This intriguing planet exists in the habitable zone of its star, Proxima Centauri. Proxima b isn't just any ordinary rock, it's Earth's cousin, located just 42 light-years away from us. This planet is shrouded in mystery and wonder. Could it be another Earth, with oceans and life flourishing on its surface? However, there's more to Proxima Centauri b than meets the eye. It isn't alone in its orbit around the red dwarf star. It has a companion. Who knows what other secrets the star system holds? Perhaps there's another planet that we have yet to discover. Proxima Centauri b receives roughly the same amount of energy from its star as Earth does from the Sun. Could this truly mean that there's water on its surface and perhaps even life? As we venture beyond our own solar system, we encounter a vast universe of exoplanets, planets that orbit stars other than the Sun. With approximately 200 billion stars in the universe, the possibilities for exoplanets are endless. Some exoplanets even wander freely, untethered to any star, like rebellious explorers in space. Among them all, Proxima Centauri b stands out as a particularly striking and fascinating planet. Its year lasts just 112 Earth days, and it orbits its star at a distance much closer than Earth is to the Sun. This means that likely one side of the planet is perpetually bathed in sunlight, while the opposite side remains in eternal darkness. Now let's discuss Proxima Centauri, the star that Proxima b orbits. Proxima Centauri is part of the Alpha Centauri triple star system, which also includes Alpha Centauri A and B. Together, these stars form the closest star system to our own solar system. Alpha Centauri A and B are a binary system, appearing as one star in the constellation Centaurus, and are the third brightest stars in our night sky with a magnitude of less than 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf star located 21 light-years away from the other two stars, roughly 4 times the distance between Earth and the Sun. It is, in fact, the closest star to us, as its name implies. Proxima means nearest in Latin. Discovered in 1915 by Scottish astronomer Robert Thorburn, Proxima Centauri, despite being our nearest celestial neighbor, is not visible to the naked eye. It has an apparent magnitude of 11.13, which is much fainter than the visible limit of 6.5. Nonetheless, don't let that fool you. Proxima Centauri is still a star worth marveling at. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a great deal of energy, but the internal convection processes at their cores keep them shining for trillions of years. In fact, Proxima Centauri will remain a stable main-sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it experiences regular and intense variations in brightness. As a low-mass star, its habitable zone would be much closer than the Sun's, projected to be between 0.23 and 0.54 astronomical units. However, it's not as livable as it appears. Proxima b is bombarded by intense ultraviolet radiation from its star, many times stronger than the radiation we receive from our Sun. This radiation is so powerful that even the lightest particles of hydrogen could be stripped away, not to mention nitrogen and oxygen. But just because a planet is at the right distance from its star doesn't mean it can support life. Proxima b may not have a stable atmosphere, which is crucial for regulating temperature and maintaining a water-friendly surface. Without it, living organisms would be vulnerable to harsh space weather, making life nearly impossible. So while Proxima b might seem Earth-like on the surface, it is far from being able to support life. Many remain skeptical, as various factors render it unsuitable for habitation. The quest to uncover the truth about Proxima b continues, and some still hold hope. One instrument that has captured the attention of astronomers is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and will help us determine whether there is life on Proxima b. As with all scientific endeavors, things are never as clear as they seem. Various modifications were required to ensure that the James Webb Telescope delivers accurate images. Abby Bend, a theoretical physicist at Harvard, explains that if a planet like Proxima b can absorb light from its star, it can also emit it as infrared light. The James Webb Telescope is specifically designed to detect infrared light, capturing images of this light on the planet's surface and searching for patterns that could confirm the presence of water or an atmosphere. However, what if the planet has an atmosphere that isn't conducive to life? The mere presence of an atmosphere doesn't guarantee the existence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima b could be similar to Venus, with a thick atmosphere that is generally denser than Earth's, accompanied by extreme heat that would make it impossible for life to exist. The journey to unravel the mysteries of Proxima b isn't without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, astronomers feel the pressure to find a way to observe planets like Proxima b. The stakes are high, but the rewards are even greater. The opportunity to explore the unknown and unveil the secrets of a distant planet that holds the potential for life is a pursuit worth pursuing. If the exoplanet were habitable, could we one day visit it? Being the closest exoplanet to us makes it especially exciting, almost like exploring our infinite backyard. Even more captivating is the fact that it is roughly the same size as Earth, and its position in the habitable zone suggests it could indeed have conditions suitable for life. Proxima b's proximity also makes it an ideal target in our search for life beyond Earth. With it being so close, it presents an incredible opportunity for interstellar missions. Imagine the chance to explore this Earth-like exoplanet. Although we can't yet go there, it is certainly on the radar for future missions. As technology advances, it is one of the most thrilling quests in the field of space exploration. However, it's no simple task. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. Nevertheless, a solution has been proposed: solar sails. These ultra-thin sails could be used to propel a spacecraft to the Alpha Centauri system, with Proxima alongside it. This technology utilizes solar pressure to keep the spacecraft on course, eliminating the issue of running out of fuel. Here's something even cooler. This cutting-edge technology could provide insights into the possibility of life on other planets like Proxima b. However, as with anything ambitious, there are limitations. For example, the presence of an atmosphere doesn't necessarily ensure the existence of life. Proxima b could be akin to Venus, with a thick, hot atmosphere that is inhospitable to life. Moreover, the James Webb Telescope has the capability to detect such light if it reaches a brightness of only 5% of the daytime side. Now, 5% might not seem like much, but when dealing with a star that is typically dimmer than our Sun, it's quite significant. If Proxima b has advanced technology, it might be using bright orbital mirrors to reflect sunlight from the day side to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being colossal gas giants, while others resemble our own Earth. But what do we know about them? One type of exoplanet that has caught the attention of space specialists is the gas giant. These planets are similar in composition to Jupiter and Saturn but are much larger. Some of these behemoths have been dubbed super Jupiters, overshadowing even the largest planet in our solar system. Yet that's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a scorching environment with temperatures high enough to melt metal. Imagine seeing such a planet up close, with its violent storms and intense heat. In addition to gas giants, there are also Neptunian exoplanets which have sizes similar to Uranus and Neptune. Among these are hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets often remain shrouded in mystery, as their atmospheres are difficult to study from a distance. We shouldn't overlook terrestrial exoplanets, which resemble our own Earth. These planets vary in size, ranging from smaller than our world to twice its size. There are even super-Earths, which have masses over twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets recently discovered is Proxima Centauri b, which orbits the star of the same name. This planet is classified as a super-Earth, with a rocky mass of 7 Earth masses. Although it is close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri b is not alone. It has a companion, Proxima Centauri c, which is significantly farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more interesting about Proxima c is that it appears to be an exceptionally bright world, possibly due to the presence of a ring system. There's more to uncover in the Proxima Centauri system. In 2019, astronomers detected a change in the star's radial velocity, which could be the result of another planetary companion. If confirmed, this planet would be known as Proxima Centauri d and would be roughly the size of Mercury or Mars. Imagine a universe where the night sky is filled with stars as well as countless other planets, each with its unique structure and orbit. The universe is full of surprises, and exoplanets are just one aspect of it. With new discoveries being made all the time, it's an exciting time to be an astronomer. While we don't yet have a precise count of exoplanets, we do know they exist, just as we are aware of the stars that illuminate the universe. However, exoplanets are not easily detectable, requiring advanced technology and sophisticated telescopes to identify them. These planets are often obscured by the glare of their host stars, making them difficult to study. Nevertheless, with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be seen by the telescope, far enough from its host star to avoid being obscured, and young enough to be hot and visible from Earth. These criteria limit the number of exoplanets that can be directly imaged, but they provide fascinating glimpses into the characteristics and composition of these distant worlds. Exoplanets are most commonly discovered through the changes they induce in their host stars. The gravitational influence of an exoplanet can cause its host star to wobble, and this radial velocity can be detected by astronomers. The Kepler Space Telescope utilized the transit method, measuring the dimming of a star's light when an exoplanet passes in front of it. This technique has provided valuable information about exoplanets, including their size, distance, and temperature. Here are some fun facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones? Or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces. Exoplanets in our solar system can also have natural satellites, known as exomoons. With over 4,000 exoplanets discovered so far, we know they exist in abundance throughout the universe. Hot Jupiters, with their mass and rapid rotation, are the easiest to find, but countless other exoplanets are waiting to be discovered. NASA's James Webb Telescope is revealing the secrets of the universe, one discovery at a time. This remarkable telescope has been gathering data and capturing stunning images of the universe, unveiling previously unknown wonders. Recently, it made headlines with a groundbreaking discovery that will forever change our understanding of the universe. NASA reported that the James Webb Space Telescope has found the first definitive evidence of carbon dioxide in the atmosphere of a planet outside our solar system. This discovery provides vital information about the planet's composition and evolution, offering us a glimpse into the secrets of the universe. This gas giant planet orbits a Sun-like star 700 light-years away, and this finding represents a significant step in our quest for extraterrestrial life. NASA Administrator Bill Nelson stated that this discovery will offer us a new perspective on the universe that we've never seen before, igniting excitement among astronomers and scientists worldwide. But that's not all. The James Webb Space Telescope has been busy capturing extraordinary images and gathering data about the universe in the infrared. The light from a young outflowing protostar, named 110 IRS-4, illuminates the cool, wispy cloud material, while the orange dots behind the cloud reveal the light from distant stars obscured by the ice in the cloud. This remarkable study was part of Webb's Ice Age project, which aims to investigate the evolution of ice from its formation to the development of cold comets. That's not all. The James Webb Space Telescope has also mapped the inner workings of a dusty disk surrounding a nearby red dwarf star, imaging it for the first time at these light frequencies in the infrared. This discovery provides significant insights into the formation of planetary systems and could help us understand how our own solar system was formed. The James Webb Telescope has offered unprecedented views of Proxima b, revealing exciting possibilities about this potentially habitable exoplanet. As scientists study this intriguing planet, which resides in the habitable zone of its host star Proxima Centauri, they aim to uncover whether it could be akin to Earth. Located just 42 light-years away, Proxima b is often described as Earth's cousin. The possibility of water and life existing on its surface has generated significant interest. Proxima b orbits a red dwarf star, Proxima Centauri, which is part of the Alpha Centauri star system, along with Alpha Centauri A and B. These stars are the closest to our solar system, and although Proxima Centauri is the faintest of the three, it's a stable, long-lasting star. Red dwarfs like Proxima Centauri have long lifespans and are among the most efficient in energy production, shining for trillions of years. However, they can also exhibit intense stellar flares that might pose challenges for any potential life on nearby planets. The habitability of Proxima b is still debated. Despite being in the right zone, it might lack a stable atmosphere, which is essential for protecting potential life from harmful radiation and temperature extremes. Proxima b's intense exposure to ultraviolet radiation from its star could strip away vital elements like hydrogen, nitrogen, and oxygen, making conditions harsh. Many scientists remain skeptical, noting that while the planet appears Earth-like in size and position, the actual conditions may not be conducive to life. The James Webb Telescope plays a pivotal role in investigating these questions. Launched in 2018, it is designed to observe infrared light, which can provide clues about the composition of exoplanet atmospheres. For instance, if Proxima b has an atmosphere that retains heat or contains water vapor, the telescope could detect these signatures. However, Ed Turner, an astrophysicist, warns that the mere presence of an atmosphere doesn't guarantee habitability. Proxima b could resemble Venus, with a thick, inhospitable atmosphere and extreme temperatures. The quest for understanding Proxima b is not without challenges. Observing exoplanets requires advanced techniques to counteract the glare of their host stars. Direct imaging has become possible with technological advancements, allowing astronomers to glimpse the characteristics of these distant worlds. The gravitational influence of a planet can cause its star to wobble, leading to detectable changes, while the transit method involves measuring the dimming of a star's light when a planet passes in front of it. Beyond Proxima b, the universe is teeming with exoplanets, each offering unique insights into planetary formation and evolution. Some of the most exciting discoveries include gas giants that can be significantly larger than Jupiter, as well as smaller terrestrial planets that might bear similarities to Earth. The variety of exoplanets includes super-Earths, which can have rocky compositions and sizes greater than our planet, and hot Jupiters, which orbit extremely close to their stars, resulting in high surface temperatures. Recently, the James Webb Telescope made a groundbreaking discovery by detecting carbon dioxide in the atmosphere of a distant planet outside our solar system. This planet, a gas giant orbiting a sun-like star 700 light-years away, offers crucial information about its composition and the potential for understanding the conditions necessary for life. As the telescope continues to capture extraordinary images and data, its mission to unravel the mysteries of the universe and the potential for life beyond Earth remains more relevant than ever.